What's up? Hey, we're on page 540, and we're talking about the last bits of information you need maybe to solve some problems with 45, 45, 90-degree triangles. Number 9, highlight. In triangle ABC, in the worked example with reference to angle A, this one, verify that the side length ratios, that's the side opposite the reference angle A and the hypotenuse, and the side opposite the reference angle and the side adjacent to the reference angle are constant in similar right triangles. That is what we completed every moment we had an opportunity to. Measure the sides, figure out what their ratio is, compare the measurements, and we get this consistency in our measurements. So like in triangle ABC, and then compare it to our triangle ADE, this ratio produced 0.7. In the other situation of triangle ABC and triangle ADE, this ratio of opposite to the adjacent side produced 1 and also 1. So this means that we have some facts about 45, 45, 90-degree triangles that we can use. Number 10, given a side length of x, unknown, right? Determine the lengths of the other sides of the 45, 45, 90 triangle. And somewhere back in like module 2 or in a previous like lesson, or even just searching it, you can Google this. We came up with x and x square root 2 for the side lengths. So this is the hypotenuse. Notice that the reference angle, I should have identified that first. The reference angle is M, which means the opposite side is now over here and the adjacent side is on the bottom. We never circle the 90-degree angle as the reference angle, but it's the exact same thing as this example, this flipped. Determine each side length ratio. So the opposite side length, yellow, to the length of the hypotenuse, green. And if I use the letters that are given in the triangle here, that would be x over x square root 2. When you have something like x on the top of a fraction and x on the bottom of the fraction, those can reduce. But you're not left with nothing up there. You have something in that numerator, and the something that will remain is 1 over the square root of 2. Keep going. The adjacent side length, and compare that to the length of the hypotenuse. So the adjacent side length to the hypotenuse. So we have x over x root 2. For the exact same reason, the x's reduce, and we will be left with 1 over square root 2. Last one, the opposite side. It's important for the coloration. This is actually trying to prepare you for the big idea of this entire topic 2, trigonometry. So right here, if I can give you a shortcut, this is trigonometry. Ooh, title it. This is trigonometry. Trigonometry. There we go. I got to figure out how many O's and O-N-O's I needed in there. Okay, so the side length that's opposite would be x, and the adjacent side length would be x. When they reduce, we get an answer of 1. Now I'm willing to bet, let me go get my calculator, but I'm willing to bet that this 1 divided by the square root of 2 is something we've seen before. Let me try this out. Hey Siri, what's 1 divided by the square root of 2?
1 divided by square root of 2 is approximately 0.7071.
What? This right here is actually that number. That's the thing I need you to know about. This is trigonometry. The answers to these two fraction answers, the decimal approximation for these two fractions are the decimals that we got from our examples. This is the exact answer. And of course, the 1 because of the opposite to adjacent fractions. Determine the unknown side lengths. This is the part right here. So rationalize the denominator. I'll make a 1 minute short, or there already is a 1 minute short on the concept of rationalizing the denominator, so stick around for that. But the rest of this is going to be using our information to solve. So the diagonal of the square is 60 centimeters. I'm going to highlight that green because I want you to recognize it's a hypotenuse. Then if we determine the unknown side lengths. So if I pick a side and call it x, this is supposed to be a square. So all of the sides are x. And we just need to figure out one of them. And when you notice that x is in both of those locations, it's just like this triangle where both of the x's in this triangle are the side lengths. So I'm going to bring that same color scheme down to the problem, and I'm going to highlight x here and in orange, and highlight x here in yellow, because those are supposed to be the sides, the legs of a 45 degree triangle. I also know this is 45 degrees because when you draw that diagonal, it's going to cut the angle in half. That's a fact about quadrilaterals. Okay. When you're given a diagram and you're given information, you need to know where that information has to go. So that 60 is on the hypotenuse. And I'm going to highlight it green so I know that that number has a home. And I'm going to go to the green line and I'm going to highlight and I'm going to put in that number 60 centimeters. Determine the unknown side lengths. We have this fraction up here. We have this fraction of 1 over the square root of 2. And if it was yellow to green is this fraction, then we can take this triangle and take the yellow and the green of this triangle and write it as x over the square over 60. So highlighting, by the way, 1 and x are all referring to the opposite side. Square root of 2, and 60 are all referring to the hypotenuse. Now what we need to do is take this proportion and solve for x. Not even cross multiply. Cross multiply is actually doing too much. But if you're stuck, you could cross multiply. But the better, first and only thing that you actually have to do is to multiply both sides by 60. And 60 over 1, so it's a fraction. Then you multiply straight across to get 60 over the square root of 2 equals x. Hey Siri, what's 60 divided by the square root of 2?
60 divided by square root of 2 is approximately 42.4264.
42.4264. That's approximately equal to x. So this concept over here, rationalize, we'll do this in a 1 minute video. But there we go. We have x, the side of the square. In fact, because of the 45-90 relationship, this x is also that amount. And so is that one, and so is that one. And of course, the one we originally found. They're all approximately 42.4264. Let's do the last question of this lesson, of this activity. Mina is picking oranges from the tree in her yard. She rests a 12-foot ladder against the tree at a 45-degree angle. By the way, don't rest a ladder at 45 degrees. That's really like laying the ladder down. The ladder needs to be up higher. But anyway, math. Okay, so I'm gonna say you got to draw it. We got to draw this scenario. We got to draw the tree. You know, practice your leafy like treeness. We got to draw the ladder. I'm trying to draw it at a 45. Then I'm going to make, in fact, I'm using the line on the bottom of the page to make the base of the triangle. What I need to do now is highlight matching amounts. So I have hypotenuse, adjacent side, of course, reference angle. And then last of all, the height of the tree is the opposite side. If we want to figure out how far is the top of the ladder from the ground, that's this side. So x will go right there. And then the 12-foot ladder is what's balancing here. In fact, draw it like a ladder. 2 lines, some rungs. There we go. We got a ladder. We got 12 whole feet of it. But this fraction, no, not fraction. Fraction is the wrong word. This ratio could be the ratio, set it up, fraction equals fraction, where we have the opposite side over the hypotenuse. Oops, there we go. And if I use my resources from above and from above, it's this fraction, 1 over the square root of 2. This is always going to be the ratio for 45, 45, 90-degree right triangles where the opposite side and the hypotenuse are used to create the fraction. So if I have bigger numbers than 1 and square root of 2, those matching numbers go in the same location as the original fraction. And 12, because 12 is the hypotenuse. Now just like 12a, 12b, same steps. But the setup is the important part. And the setup is, it's the fraction 1 over square root 2. Multiply both sides by 12. 12. 12's reduce. Hey Siri, what's 12 divided by square root 2?
12 divided by square root of 2 is approximately 8.4852.
Now I'm giving 4 decimals. Siri gives 4 decimals. That's a good number of decimals to give when square roots are involved. That is it. That is solving equations. You definitely need all of the practice you can get. So do your Mathia, do the extra papers that I or your other teachers or whoever are giving them to you, and then really practice this idea until it is a easy skill for you to replicate, because it is actually one of the best things to learn from this class, the relationship of sides of right triangles and how we can apply them to solve problems. Thanks for watching this episode. This has been the rest of Activity 1. Up next is page 541. And on that video, we talk about 30, 60, 90 triangles, the other type of special right triangle. Thanks for watching. I'll catch you in the next episode.